Good morning, everyone. My name is Dina Amor Elsinining, and today we are be talking about the different mathematical models in investment. In the realm of investment and financial analysis, mathematical models play a critical role in decision making. These models help investors, analysts, and decision makers better understand risks, optimize returns, forecast future scenarios, and manage uncertainties. They are essential tools for managing portfolios, valuing assets, assessing risks, and making informed financial decisions. Mathematical models in investment can be broadly categorized into different types depending on the specific needs and objectives of the investor. One crucial area within investment analysis is cost estimation, where mathematical models help estimate and predict the costs associated with a particular investment or project. This model provides a structured, quantitative approach to evaluating potential expenditures, helping to prevent cost overruns, allocate resources effectively, and optimize financial outcomes. In this lesson, we will dive deep into cost estimation models, which are pivotal in both project investment analysis and in understanding how costs evolve over time as a project progresses. What are cost estimation models? Cost estimation models are mathematical tools used to predict the costs associated with projects, investment, or business operations. They are essential for budgeting, financial planning, and evaluating the feasibility of projects before they commence. By using historical data and establish relationship between key project variables, these models help to forecast the total costs over time and identify possible cost drivers. For investors and business managers, cost estimation models provide the necessary data for making informed decisions. These models can be used for a range of projects from constructions and infrastructures to technology development and manufacturing. There are several different types of cost estimation models, and each has its unique advantages and limitations. In this lesson, we'll focus on two primary types: the parametric estimation models and the learning curve models. Let's explore both in details. Parametric estimation models use mathematical equations based on historical data to estimate costs. These models rely on parameters or variables that are key to the project or investment, and they derive cost predictions from these parameters. The main idea behind parametric models is that given a specific set of input values such as the size of the project, production volume, or other measurable attributes, the model can generate a cost estimate. How they work? Parametric models typically work by identifying key project variables that directly correlate with costs. For example, if you are estimating the cost constructing a building, a parametric model might use data such as square footage, location, and material costs to provide an overall estimate. There are different benefits that parametric models provide. The first one are the data-driven and objective. Parametric models provide cost estimates based on historical data and statistical relationships. This objectivity reduces the risk of bias or subjective estimates. The second one is the quick and flexible. These models are generally faster to implement compared to more complex models. They can be updated easily with new data, ensuring that cost estimates stay relevant as conditions change. So the third one is the supports decision making. So they help project manager and investor make quick decisions, especially when multiple options or alternatives are being considered. And the last one is the project comparison. So parametric models can be used to compare different projects or investment opportunities based on similar parameters, helping investors choose the most cost-effective option. So, if there are benefits, there are different challenges also. So, the first challenge that parametric models has is the data dependency. So, the accuracy of parametric models depends heavily on the quality of the historical data. If the data is inaccurate or incomplete, the cost estimates will also be unreliable. So, the second one is the assumes data validity. So, these models assume that the relationship between variables such as project size and cost are consistent over time. So, this may not always be true, especially in rapidly changing markets. So, next is model validation. So, proper selection and validation of the model are crucial. If the wrong model is used, the results may be misleading. So, and the last is the limited scope. So, parametric models may not capture all potential cost drivers such as unexpected market fluctuation or regulatory changes. Example, suppose you want to estimate the cost of constructing a building. A parametric model might use historical data that suggests the cost per square foot for construction in a particular city is $200. So, if your building project is 10,000 square feet, so the estimated cost will be, for our solution, let's see this. Estimated cost is equals to 10,000 times $200. So, is equals to $2 million. So, that will be your estimated cost in constructing a building. So, the next type of cost estimation models is the learning curve models. So, learning curve models, also known as experience curve models, analyze the relationship between cumulative production or experience and the reduction in cost or time per unit of output. The core idea is that as production or experience increases, the time or cost to produce each additional unit decreases due to increased efficiency, improved techniques, and better resource utilization. So these models are particularly useful in industries where economies of scale and improvements in efficiency over time are significant. In investment terms, learning curve models can predict how costs will decline over time as a company or project gains experience and operational efficiency. So, learning curve models are based on the assumption that with every doubling or cumulative production or experience, the unit cost will decrease by a fixed percentage. So this relationship is often modeled using a power law or an exponential function where the cost per unit declines as the cumulative output increases. So the benefits of this are improved cost prediction. So learning curve models allow for more accurate long-term cost projections as they take into account the improving efficiencies over time. So it also investors and project managers can evaluate the effect of experience and scale on the cost structure, which help in long-term financial planning. So, it is also has an application to repetitive processes. So, these models are highly effective in industries like manufacturing, construction, or any area where repetitive tasks or processes lead to incremental improvements in productivity. So, but the challenges are the data intensive. So, learning curve models require a significant amount of historical data on cumulative output or experience, and such data may not always be available or reliable. So, there is also a challenge between the assumption on of continuity. So the model assumes that cost reductions will continue in a predictable pattern, which may not always be the case, especially in industries that face technological or market disruption. So the challenge also they face is the oversimplification. In some cases, learning curves may oversimplify the complexity of cost behaviors, overlooking factors like market changes, supply chain disruptions, or regulatory shifts. There are three examples of learning curve models. So, the first one is the power law model. This model suggests that the cost to produce each additional unit decreases at a fixed percentage as production doubles. So, the second one is the experience curve model. Similar to the power law, this model emphasizes the reduction in cost due to the cumulative experiences over time. And the last one is the S-curve model. So this model assumes that cost reductions are not linear but follow an S shape where initial improvements are rapid, then slow down as efficiency gains become harder to achieve. For example, suppose you are producing widgets and the cost to produce the first unit is $100. So, according to the learning curve, every time you double production, the cost per unit decreases by 20%. So, here is the solution. So, the cost to produce the first unit is $100. So, the cost to produce the second unit after doubling production would be $100 times 0.80, wherein it is the 100% less 20% because the cost per unit decreases by 20%. So, $100 times 0.80 is equals to $80. So, the cost to produce the fourth unit would be $80 times 0.80 is equals to $64. So, in conclusion, mathematical models, particularly cost estimation models, are invaluable tools for investment decision making. So, parametric estimation models provide quick data-driven cost predictions, while learning curve models help predict cost reduction due to increased experiences and operational efficiencies over time. So, both types of models have their advantages and challenges, and understanding their use cases and limitation is key to making better investment decisions. So, these are all my topics. So, for further more information about the mathematical models in investment, my co-teachers will explain further. Thank you for listening. Bye-bye and good day.